Assalamu alaikum. Welcome to Practical Numerical Methods for Scientists and Engineer. Today, this part is part 2 of Module 2 for loops and conditions in MATLAB. Today, we'll start with function. How to create function. How to create function in MATLAB. So what is function? Function is just a files written in order when you insert some inputs or outputs, you can perform specific sentence or instructions. For example, if you want to calculate something, so just you can put the function name, and after putting the function name, you can put your inputs, and then the function automatically calculated the output or do specific work, something like this. Okay, now we have, in order to perform function, to create function in Blackboard, in MATLAB, we have certain different forms to write the function. So function, we actually in the script file we write function, then we put the sentence, then end. If you are working in Octave, so it's end function in Octave. In MATLAB, it's only end. Okay. So function, the default way is function, then output. Okay, so this output maybe X, maybe Y, whatever the output you want, then equal. Then put the function name you want to call it. So for example, so whatever the function name you want, XYZ. For example, this is my function name. And between parentheses, put the inputs. Okay. Later you will define these inputs. Okay. Also, the other way of function is if there is more than one output, then you have to put them in square brackets. So output 1, output 2, comma, output 3, and equal, then put function name, and then put the inputs in parentheses. Okay. Sometimes you don't need to put inputs. Okay, I mean you can later put the inputs as input file or something like this. So just you want to recall, or even the function is not related to input. So in this case, just you put function, and then what's the output equal function name. If your function doesn't have outputs, or the output will be generated separately than the function, okay, so then we will see later examples for each one of them. So function name, inputs. Notice here we didn't put equal, so just we put function name, and then inputs. Okay, the last form is function and function name. So let's try. I think the best way is to try each of them. Okay, before trying, we have some tips here. It's recommended to put percentage and add comments to your script. Why? Because sometimes you forget why you built this function. So you can just in command window, you can just put help and then put the function name, so it directly will recall the comments you add. Okay, these comments may be the function, how does it work, or even the inputs meaning, letters meanings, and that's it. Okay, so also it's very important when you save the function file, you have to save it, the file name should be exactly the function name. If the file name is not exactly the function name, then your function will be not work. So now let's take simple example. Now create a function to find the area of triangle when its height and base are given. So now I put this comment to recall it later. This function is to find the area of triangle when its height and base are given. Okay. Now function. So now I have input and I have output. So the best way to use the format, this format, okay, function, then output equal function name and input. So once you start with function, you remember that you have to finish it with end. Okay, function. What is my output here? My output is area. Okay, so function area, I will call my output is area, equal, the function name will be triangle area. Remember that you can't put here, you can't put like space between the function. You can put underscore, but you can't put space between names. Okay, so I call it triangle area, and then the inputs are h and b, height and base. Okay, then I put some here, notice h is the height of the triangle and b is the base of the triangle. Then I calculated area is 0.5 times b times h and then end. Okay, now and save it. Now try in the command window, just put the function name triangle area and then 5 and 2. 5 is the height and 2 is the base according to the same order. So directly it gives me the answer is 5. Let's go for more complicated example. So here, create a function to calculate the velocity of free falling bungee jumper, where the velocity of the free falling jumper is defined from this equation. Okay, here v is the velocity in meter per second, g is the acceleration, is the acceleration due to the gravity, m is the mass, cd is the drag coefficient in kilogram, tan h, and then t is the time in second. So it looks complicated, but in MATLAB you can perform it very easily. So can you imagine how can we create this function? Okay, so we need function name. We need this is my output. Velocity is my output. And what is my input? Since g is defined, so I can exclude it. G I can. It's not doesn't it. We don't need to put it as input. So we only need to put the mass, body mass, and the drag coefficient. Okay, and also the time. So once I put it, so it will be calculated the velocity directly. So how can I write the script? The script is very easy. First, I started with definition, with defining the script file. So this function is will be used to define the velocity of the falling bungee jumper, where the velocity of the free falling when time at t, mass m, the drag coefficient. This is the drag coefficient are given. Okay, function. Then function output velocity equal the function name, I call it bungee velocity. Okay, and the input will be mass, time, and cd. Okay, and then I define the g as 9 point. No need to put it as input. If you want to put it as input, you can, but just to make it very short, so I make it take the default value, and then the output velocity equal square gm over cd, then tan h square gcdm times t. Okay, now save the you have to save the file to be the same as bungee velocity. Now once you bungee velocity and put the inputs, okay, so it directly will calculate the velocity. Now try to put help and bungee velocity. So here it will put what you put here. Okay, this function will be used to find blah blah blah. Okay, so that's why it's very it's recommended and very useful to add comments to your function to help you to remembering and recognize what this function is used for. Please try it now. Now, let's try another option. That function we will not put output. We'll just put function name and inputs. Why? Because I will display the results in another way than the function. Let's check this. So I will do the same for the previous example. Okay, so function bungee velocity 1, I put it 1 here because it's different than the previous I want to keep the previous example and make another file. Okay, so bungee, this function, there is no output, bungee and then input, then I calculate it. I put the value of g and then considered v is squared and put the equation based on the inputs. Then after that I put the output displayed. Please print f the velocity of the jumper at something here. Second is here meter per second, and then the inputs here at this the first time will be time and the second part will be velocity. Please review the previous lesson if you don't know how to use the display input output function in MATLAB. So here once I put the bungee velocity 1 5 10 minus 3, so directly it will show velocity of the jumper at 10 seconds is 12.79 meter per second. So this is another example related to fluid mechanics. For it will be interesting for who works in fluid mechanics. Create a function to calculate the loss coefficient and head loss of the pipe when the friction factor, pipe length, pipe diameter, and fluid velocity are given. So who works in fluid mechanics know that the loss coefficient Kf is 4FL over D, and HL head loss is Kf times V squared over 2G. So where Kf is the loss coefficient, for F is the fanning friction factor, L is the height of is the length of the pipe, and D is the diameter of the pipe. And once you calculate Kf, you can calculate head loss. So head loss equal Kf, this is loss coefficient, times squared of velocity and over 2G. So you can make script file, function file for this. So okay, so we'll choose the function name and input output. Okay, so just I will put this one to remind me. So I will create a file and put the notice here, create a function to calculate loss coefficient and head loss of a pipe. Function, okay, then function loss, friction loss. And what is input? Input will be F, L, D, and V. Okay, then we put G as 9.81. Then we calculated Kf. Notice here we don't put output because we already put it here. So Kf is 4F L over D, and H is Kf V squared over 2G. Then print F. The pipe loss coefficient is I need 2 decimal, and its head loss is also decimal. Okay, meter. So the first one will be Kf and the second one will be HL. So once you save the file and then recall the function again, friction loss 0.1, 20, 0.2, 0.4. So directly the pipe loss coefficient is 40 and its head loss is 65. As you can see, it's an interesting way. You can do anything you want, make a conversion, anything, so by simple codes. So this is end of this tutorial. Thank you so much and see you in another lesson.